mammography students. Okay, here we go. This is the real meat of the subject here. Chapter 7, Mastering the Mammography Examination, Part 1. We're mainly going to go over the basics of our equipment and accessories and the craniocaudal and medial-lateral oblique, which is done for the screening exam. So let's get started with that. Of course, producing quality mammography images while providing a positive patient experience is a complicated process and requires the ability for the technologist to blend their interpersonal skills with their technological competencies. So, assuming that the equipment performance has been verified, the technologists in the field of medical imaging agree that the major factors affecting image quality are determined by the technologist's performance and the compliance capability of the patient. And when we talk about technologist performance, we mean positioning. There's an artistic component to mammography, and it's like anything else that takes a lot of time and experience to get good at it. That is the artistic component. Some people are going to have more artistry capability in them than others, but it does take a matter of time to really learn how to do that mammography dance well with your patient. There's many tools of the trade, and we'll touch on all of this as we're going through the lecture, and when you really get into the chapter in the book, it really goes into some great detail. The MQSA requires that there's 2 sized image receptors for analog imaging, but when we went to digital imaging, that wasn't possible. So the detector plate started out being only around the 18 by 24 size, but they have now increased them to the 24 by 30. So we have different paddles and different receptor fields on this one imaging device, receptor device, and we have different paddles to be used because you don't want to use the big paddle on a petite patient and vice versa. There will be accessories to provide magnification mammography. There's platforms that give you the magnification by putting an air gap between the receptor and the patient's breast, and there's a couple different sizes for that. Of course, the compression devices and different types of additional view type of devices that we'll be using. Some of the accessories will be for doing invasive procedures like needle localizations or biopsies. So we'll get more and more into that, but let's first get started with the basics. So although positioning is only one aspect of the exam, the goal is to screen the entire breast adequately. The 2 primary projections are the craniocaudal and the medial-lateral obliques. These 2 views complement one another. So in other words, if there's areas of the breast that are missed on a craniocaudal, that should be picked up on the medial-lateral. No single view alone will view the entire breast. The technologist is the only person who's going to view the breast under compression, so the technologist will need to ensure visualization of tissue to be included on each of the projections, that there are not skin folds that are going to cause artifact or be problematic. And the technologist is the one who's going to tailor each exam to each patient. So we'll need to understand, what size of field is appropriate for the patient, what is the appropriate compression device, and other special accessories that are needed for that individual patient. The guidelines for labeling the positioning, there's uniform labeling of images so it avoids confusion. The labeling is actually done electronically, so it's actually selected on your workstation. The view typically is going to describe the X-ray beam direction. So in other words, and the label itself will be always be placed near the axilla. So in other words, if we're doing a medial lateral oblique, it means that the beam is entering the medial aspect of the breast, exiting the lateral aspect. As long as the technologist selects the correct view icon at the workstation, the computer is programmed to display all information correctly. So we need to sanitize the imaging receptor device. You want to wipe down your compression device and image receptor surface between patient exams, and you should always do this in front of the patient. You want the patient to know that this stuff is being cleaned before we start coming in contact with her breast. You always want to use a cleaning solution that's recommended by the machine manufacturer, because if you are using something that's not recommended, it could start to disintegrate the plastic or the carbon fiber. The protocol and procedure for sanitizing is an MQSA requirement, and routine cleaning is different from disinfecting the unit after contact with bodily fluids. So it's important to understand that, and you can find those in your MQSA quality guidelines. So guidelines for positioning, patients are going to have skin folds. Not all images with skin folds need to be repeated. However, it's wise to try and alleviate skin folds when you're positioning and compressing the breasts. However, if you can't avoid it, if you can follow breast tissue trabecula into, through, and out of the skin fold, there's no need to repeat. If you cannot, then you need to repeat. To facilitate skin fold removal, you iron out or you knead out that fold before the compression is lowered. You can ease the skin fold forward, but you do not want to ever pull skin off of the image. Do not sacrifice breast image to eliminate a skin fold. You will find when you start doing mammograms, skin folds tend to occur in certain patients more than others. So guidelines for positioning the nipple in profile. Most nipples are centrally located, so the nipple is in or is close to profile. It must be in profile on at least one of the standard views. And that's one of the standard views on each breast. So with larger breasts, the nipple often projects inside the breast. So what happens is if a woman has very large or voluptuous breasts, when you get that breast up on the image plate and begin to compress, it compresses either underneath the breast tissue or on top of the breast tissue. More often, I think it would be underneath the breast tissue. If you just cannot get that nipple in profile without sacrificing breast tissue, then you use a BB to denote that that's the nipple. Indications for nipple in profile. The nipple is indistinguishable from a mass if you don't put a BB on it. It could be suspected as a subaureliar abnormality. You need a nipple for proper measurements for needle localization, and you want to have the nipple in profile when a patient is experiencing nipple discharge, and always when you're imaging a male patient. So here's some compression guidelines. The use of tilting compression device on non-compressible breasts. Not all manufacturers have a tilting compression device, but what the tilting compression device does is, as you know, if you look at the mound of the breast, it's harder to compress that posterior tissue than it is the front tissue. If you cannot get that tissue to compress, then the only way you can get compression is if it's tilting. Usually patients that you're not going to be able to compress the breast are going to be young patients that have very glandular tissue and very firm tissue. When you are compressing, there's a foot pedal that motorizes the compression initially. And then once you feel like you have that breast anchored pretty good, you can let off the foot pedal and then do the final fine compression using a manual mode, which would be the turning of a knob. You don't want to undercompress, but you don't want to overcompress. And so what we say is, once you get the lady's breast in compression, you kind of tap the skin, and if it feels taut, then that's where you want to be. And the way that you know if the tissue is taut or not is if you feel the skin in between your thumb and your index fingers there on your hand. When you're just relaxed, it's very soft. If you clench make a fist and then touch it, that's taut. These are the 7 reasons for compression. It reduces the dose to the patient. It makes the breast an even thickness from base to apex. And that's really what reduces the dose to the patient. It separates islands of glandular tissue, so it helps to eliminate some of the superimposition of tissue. It improves geometric resolution because it gets all that tissue closer to the imaging device. It prevents motion and reduces scatter and increases the contrast. We cannot live without it, unfortunately. Guidelines for positioning and avoiding motion. The motion in a mammogram, like any other radiograph, can cause blurring. And sometimes it can be hard to recognize, or it takes a while to really recognize motion on an image by the technologist. It most often is going to occur on the MLO projection, and the areas most vulnerable to motion on the MLO projection is posterior inferior and then anterior central. And the reason for that is because sometimes when you're positioning that breast in the MLO, if you don't really lift that breast up and move it out onto the plate, then that lower tissue is kind of hanging there in the breeze, so to speak. And that's why sometimes if you have motion, you'll find it in that part of the breast. But it can be anywhere. Sometimes it's just because your patient moved. Guidelines for positioning, whether to have the patient stop breathing or not. There's 3 schools of opinion on this. There's no breathing needed at all because with the short exposure times and the patient's breast being firmly anchored with compression, many institutions feel that it's not necessary to tell the lady to stop breathing. There's the institutions that just say stop breathing, and then there's the others where they're asking the patient to hold their breath. It's really not recommended to have a patient hold their breath, because what they're going to do is take in a deep breath, and when they do that, they're going to want to move the chest away from the imaging device. Typically, patients, like I said, would take in that large amount of air as if they're having a chest x-ray, and you just don't want to do that. So I would say the best course of action is either to tell the lady she can continue to breathe quietly but to hold very, very still, or to just cease breathing during the exposure. I'm sure your facility will have what they determine as their protocol on this. Okay, the use of the patient history form and diagrams to indicate the moles, the scars, the locations of tattoos, bruising, infection, anything that you want to draw the radiologist's attention to. You want to make note of that on the history form, and then you want to use a skin marking system that will be visible on the mammogram. And like anything else, these are going to be available, and there will be protocol at your facility. Sometimes you can get more markings on a lady's breast than there is breast tissue. So you need to know, what to mark and what not to mark. And I'm sure there's going to be some radiologists that are going to say yes on this type of marking and no on that type of marking. But here it kind of gives you an idea. You'd use a BB type to mark a nipple. You would use a circular mark to show a mole. There's little lines that you use to show scars and so forth. So there's a preparation for positioning. It's entirely individualized to the patient. If producing excellent studies on a majority of patients, assume the method is working. So you might want to take whatever's working for you on most people and make it your method. If you're retaking or adding a lot of extra views on many of your patients, then there's something that's not right. You want to figure out what that is and correct the problem. You want to gain the patient's cooperation. You want the patient to be able to relax and feel comfortable. It's necessary in order to perform a good mammogram. The way that you gain a patient's trust is to let them know what's going to happen, what they can expect. Enlist their help and give the patient control. Let that patient know that they can tell you if something's uncomfortable, they don't feel steady in this position, they're not ready yet, it's painful. Make sure that they know that they have that control and listen to that patient. So there's mobile borders of the breast. Those mobile borders, well, you know what, I'm looking at the slide. No, this is right. Mobile borders of the breast are your inferior or your inframammary fold and then the lateral aspect. So one of the things, if you're not noticing that you're doing this already, is you're going to be using yourself, your own breasts, as as your prop. So if you, as we all know, one of the things that we all want to do is we always want to lift our breasts up to where we think they used to be, or where we want them to be. So that inferior inframammary fold, that's a mobile border. And then the other border is we want to pull that breast tissue in. That creates our cleavage. So that lateral border is our other mobile border. The fixed borders are the superior and the medial. And when you start compressing breasts, you will definitely realize that, because you're going to lift the breast up at the inferior border to get the breast up on the plate. When you start bringing that compression pedal down, you will know you can really start tugging on that patient's upper chest tissue, and it doesn't move. It's immobile. So you want to bring the mobile borders closer to the fixed borders to minimize the loss of tissue for each projection. So we'll talk about that. You always want to lift that breast up, and you always want to move the breast tissue out. Patient posture, the patient needs to be comfortable. They want to be standing comfortably. They just want to be as comfortable as they can be so that they do not tense up. If the patient tenses up, it's going to be hard to get all the breast tissue on the plate. The best posture is kind of poor posture. They kind of don't stand up real straight. You want them to kind of slump a little bit. The breasts will fall forward. They'll be looser and more mobile. And then they're going to want to hold on to something. You don't want them to put a death grip on a handrail. You want them to just rest their hand on the handrail. The back should stay somewhat straight. But I know it's going to be hard for patients to be comfortable when they're standing there with nothing on top and they're waiting for us to squeeze their breasts, but you'll get there, you'll know how to do that. So let's start talking about the craniocaudal view. So the image is, the X-ray is going to enter cranial and exiting caudally, so therefore the CC projection. You want to follow the sequence of figures in your book, 7-45 through 7-69 in the text. But essentially what you're doing is you are going to get that lady up to the plate. You're going to lift her breast up, pull it onto the plate. Make sure that you are using your hands to get as much tissue on there as possible. And then you're going to help her relax her shoulder, turn her head. You'll start bringing the compression paddle down. The goal is to try and get all of the glandular tissue on the CC view. So if you look at the bottom portion of this little drawing here, you can see that in the axilla or the tail portion of the breast, they're not getting all of the glandular tissue on. So if you were to make an image and cut that off, you'd have to come back and do an exaggerated CC to see that portion of the breast. You want to select the appropriate size of the compression device depending on the patient's size and their breast. You're going to stand on the medial side of the breast being imaged, and that is because we want to make sure that we get as much medial tissue on the CC as possible. The patient is facing the image receptor plate with their feet facing forward, and then they're going to be about a hand's width away. You want to make sure that they're relaxed, their arms are at their side, that they don't want to be standing up like a little soldier. They can be kind of slouched a little bit. And they're going to turn their head towards you. And this allows you to kind of see, if they're wincing in pain or, it's good to be able to watch the patient. Instruct the patient to lean the upper body slightly forward. The pelvis remains back. The technologist's flat hand is placed on that inferior tissue of the breast, so you're kind of lifting that breast up, making firm contact with the rib cage. So you're going to make sure your hand is back against the rib cage and you've got all the breast tissue now within your hand. And then with the flat hand, your palm up, you firmly press the patient up against the plate until you feel that natural resistance, so you know where that plate comes to. Once you have the image receptor height adjusted to the level of the elevated inframammary fold, then you place the opposite hand in firm contact with the chest wall and the superior tissue of the breast. Using both hands simultaneously, you lift the breast forward onto the image receptor. So once you get that tissue on the image receptor, you're going to remove your lower hand, but you're going to leave that breast somewhat anchored with the top hand that's got the superior tissue. And now you've got kind of a hold of the patient's both lateral and medial aspects of the breast. Now you start to bring the plate down. And as the plate comes down, you start moving your hand out. So these are things that we'll get to practice in the lab that we're going to have. So you bring the compression down until you feel that the breast is well anchored. And then you start tapping the tissue to see if it's taut. And you do your fine adjustments now, talking to your patient, seeing if she's okay. Then you're going to make sure that the patient's head and neck are not in the way of the field. They're around the face shield, slightly rotating the sternum medial toward the image receptor. You're going to elevate the other breast to make sure that it's out of the way, and then complete the rotation of the patient's body medially until the thorax and sternum are flush against the image receptor. And then if you need to, you can drape the other breast over the corner of the image receptor. You're going to make sure that you're pulling that posterior lateral tissue forward in the direction to include as much as possible. You've got your arm around the patient, resting her hand on the shoulder of the breast being imaged. So if we're imaging the right breast, you're kind of resting that arm now, your hand on her shoulder, to kind of guide her to stay relaxed in her shoulders and keep her up against the plate. You want to make sure that you're not getting too much of the upper chest tissue pulling so much that it's making a pulling sensation in the patient's neck. And you can see it, and the patient will let you know as you're compressing down. Once you've got everything in position and you've got your compression to where it's taut, you can move to the lateral side of the patient, relax their arm by her side, kind of externally rotating her hand to kind of keep the humeral head away from the field of view. And then you do the fine compression, finalize the compression to make sure that the tissue is taut. If you see any skin folds, you can see if you can smooth or knead any of those out of the way. But if things look pretty good, we're good to go. So, see why we call it a mammography dance? There's a lot to it. Okay, we've done both cranial caudals on our patient, and now we're ready to start the positioning of the medial lateral oblique. So you can follow the figures in your book on figure 7-27. Let's see, that starts on page 153. There's a little sketch of that, and then it'll go through images 7-44. So one of the keys to getting a good MLO is to angle the image receptor at the right angle for that patient. So I thought this was kind of a good picture. If you look at this patient, what they've done is they've kind of drawn a line from the humeral head to the inframammary fold, so to speak. And that is the angle that you should have. Now, sometimes depending on the build of the patient, how tall or short they are, or how pendulous the breast is, that angle may be steeper or may flatten out. So the angle could be, depending on the patient's shape, anywhere from 30 degrees up to 55, 60 degrees. It is not a set 45 degrees. If you're doing the same for everybody, you're not doing your MLO justice. Again, you want to select the correct compression device size. Like I just described, you want to custom the angle of the C-arm to the patient. So the height of the image receptor is approximately at the level of the relaxed axilla. So you want to make sure that, you know, the height of it is going to fit right in her armpit. Turn the patient with her feet and pelvis directly facing the image receptor. That's going to feel strange. They're going to want to turn their feet parallel to the image receptor, but they want to face it. Place the inframammary fold region in front of the image receptor. This is so you can pull all of that tissue onto the image receptor. Elevate the patient's arm, placing the corner of the image receptor posterior to the mid-axillo hollow, just anterior to the latissimus dorsi. So that corner of the image receptor is going to be posterior to the armpit hollow, but anterior to the latissimus dorsi. If you get latissimus dorsi in there, you're not going to be able to compress. You're going to lift the breast away from the image receptor while moving the far lateral tissue anteriorly and medial to capture the lateral tissue to the latissimus dorsi line. So you're kind of lifting that breast up and away so that you can pull all that tissue up and then pull it over onto the plate. Using both hands, you're going to sandwich the breast firmly, grasping and pulling the breast out and away from the chest wall at approximately a 90-degree angle. Then using one hand, anchor the breast out and away from the chest wall. The inframammary fold region is positioned on the image receptor. Continue to pull the breast out and away from the chest wall at an approximate 90-degree angle while simultaneously supporting the medial tissue upward. So, if you kind of grab your own breast as if you're having a medial lateral, you grab it with both hands, you're going to pretend like that image receptor is right in back of your armpit. You're going to then want to lay all of that tissue that you've got lifted up and away, roll it over onto the plate. You want to keep supporting that tissue so that it's the tissue, we want to say, is pulled up and out. When you pull up and out, it's going to get that tissue, as much tissue as possible, onto the plate, and it's going to open that inframammary fold. So you begin the compression. Slowly lower the device, skimming the chest wall surface. Gradually remove your supporting hand as the compression takes over, holding the breast in position. And then you monitor the compression contact with the bony structures of the thorax. So you want to really watch how the compression paddle is going across the patient's chest, because sometimes if patients' sternum or clavicle protrude a lot, it can be very uncomfortable. So you want to watch that. You want to get the patient relaxed as possible and as comfortable as possible, and this is done through good communication. Be positive. Tell them how good it's going. What you're doing. A common thing to do is to think out loud. Share with them what you're doing. I'm getting as much breast tissue as possible onto the image device. We want to be able to see your pectoral muscle. Let them know what you're doing. Ensure the inframammary fold is open and free of skin folds and air gaps by using your fingers to sweep medially and lateral the breast tissue downward. So what they're saying is you want to make sure that the breast tissue is there, but you want to take that belly tissue and kind of sweep it downward so that you open that up. Don't pull the breast tissue away, just kind of open that space up so you don't have superimposition of the breast tissue with the belly tissue. So I know that's a lot to talk about. It's kind of a hard thing to describe. But again, the book has excellent pictures in there for you to follow. And these are the views that we will be doing in our lab. We're going to have a lab probably towards the middle of February after we do the test for this. But I really think they have really excellent pictures in here. So go over the book and the pictures. It looks like a lot, but the majority of it is showing you how to do these positions. And then on the next part of this chapter, part 2, we'll talk about the special views. Okay, thank you.